All right, 6-6. I think this is the last lesson, isn't it, of this chapter? So we are ready for a test. Are we doing it this week or is it next week? Did I say this week? Yep. Yeah, it's Thursday. All right, so this last lesson, we'll review a little bit tomorrow. Excuse me. And then we'll take the test. I think I have one problem on the test like this, maybe two, but no more than two on this stuff right here. All right. Like you guys said yesterday, they're not even teaching anything new here. It's just examples, all right? It's stuff that you should have already learned, right? And then we're just putting it into practice. So here's what we're going to do. I'm going to give you 4 points. Oops. I thought I changed that. There we go. Now let's try it. So they give you 4 points. Here's what they give you. They give you point A, which is -1, 3. They give you point B, which is 3, 2. Point C, 4, -2. And point D, 0, -1. All right, so it says right now that it is a quadrilateral. Okay, we'll graph it here in a second. And we don't really necessarily have to graph it, but we're going to do it just so we have a little guide, all right, to see what's going on. All right, so it says classify it as specifically as possible. What does that mean? First of all, they tell you it's a quadrilateral. So we know right off the bat it's got what? 4 sides, okay? So what would be a more specific type of quadrilateral? Could be a parallelogram, could be a, what's even more specific than just a parallelogram? Could be a what? A rectangle? Give me something else. A rhombus, a square, okay? Could be something else. Maybe it's not even a parallelogram. It could be a trapezoid or it could be a kite. I think we knocked them all off, didn't we? Is there anything else? I don't think there's anything else, okay? So that's what they mean by figure out what it is specific. So what I'm going to do, I'm going to grab me some graph over here. Put it there. And what we're going to do is we're going to plot it. I think it's easier if you actually see it than just try to figure out just from those 4 points. You probably could, but I'm not going to. I am going to plot the thing. So let's put it in yellow. All right, so let's do this. -1, 3. So -1, 1, 2, 3. That's A. 3, 2. 1, 2, 3, 1, 2. 4, -2. 1, 2, 3, 4, -2. And then 0, -1 right there. Okay? Now, just graphing at it and looking at it, we may be able to guess what it is. Now, it's quadrilateral, so you know you're not going to go from there to there. Would you agree? Okay, so let's not do that. Let's go from here to here, and let's go from here to here. So it kind of looks like what? Looks like, it could look like a rhombus, yeah? Or it could be a what? Just a plain old parallelogram, right? Definitely doesn't look like a rectangle or a square, does it? All right? But it does look like it possibly could be a rhombus. It definitely looks like it's a parallelogram. So what are we going to do? We're going to take those points. How in the world would I be able to say if this thing is a parallelogram or a rhombus or a trapezoid or a kite or anything else like that? What would I do? Because I'm going to look at the sides, aren't I? Well, maybe there's something else I could look at too. What do you think? Say the midpoints. So how would that help us? Finding the midpoints. Oh, the midpoints of the diagonals. Oh, I didn't hear you say that. Did you say that? All right, so let's do the diagonals. That's a good thing to do. So you could do that. So you could draw the diagonals and you could draw the diagonals. Let's do that. And if it's a parallelogram, what would be true about the diagonals? You already said it. Say it again. They would bisect each other. Okay, so we could do that, right? We could try to find that point right there, okay, and find the midpoint of there. So we could take this point. By the way, let's grab the yellow. There we go. what did I say this one was? This was A. 3, 2, that was B. 4, negative 2 was C, and this 0, negative 1 is D. All right, so I could take AC and DB, find the midpoint of AC, find the midpoint of DB, right? But then I could find that point, but then I'd have to find that length, and I'd have to find that length. That'd be a lot of work, wouldn't it? There's something else I could do with the diagonals in order to tell me what kind of shape this is. Say it again. Okay, what would the slope do? You're right. You're absolutely right. But why are we finding the slope? You guys said earlier you thought this was a rhombus, correct? All right. What happens to the diagonals on a rhombus? They're perpendicular to each other, right? So if we can show that it's a rhombus, can somebody get that door? If we can show that it's a rhombus, then it must be a what? Parallelogram, right? But a rhombus is a more specific type of parallelogram. So what could I do to these diagonals, AC and DB? I could find the slopes of them. And if the slopes are what? What would have to be true about the slopes? Very good, negative reciprocals. Do you see how we're going back to the stuff that we learned earlier and we're recalling it, right? So the little talk we had before we started teaching, it's coming back to you, isn't it? Are you starting to agree with me now on that stuff? Maybe, maybe not. All right. Y'all done? Okay. Oh, that battery died? So which one? I can't see what that is. To the main light? Oh, it's because of that. Daggone. I've got another one over there. Are you still shooting or you're done? Okay. And you got enough good ones? Okay. Oh, here, actually, take this and just switch it with the one that's in there. I'm not going to throw it. Okay. All right. So what we're going to do is we're going to find the slopes of, let's do this. Find the slope of what? AC. All right. I put M for slope, right, of AC. Remember how to find the slope? Has it been too long? How do we find the slope? Change in what? Change in y over the change in x. So what do I mean by the change in? What do I do? I subtract the y's, okay? So AC. So here's A and here's C. Let's subtract the y's. What's that going to be? 3 minus negative 2. Then subtract the x's of AC. That's what? Negative 1 minus 4. So let's see what we get. What's that? 5 over negative 5. What's the slope? Negative 1. So the slope of AC is negative 1. Let's find the slope of what? BD or DB, right. Let's find the slope of this one. So BD, that one right there. Let's do the same exact thing. Different numbers though. All right, so the change in y is 2 minus what? Negative 1, right? 2 minus negative 1, there's BD. Let's do the x's, 3 and 0. So 3. Do you need to pass, Kevin? Kevin, are you okay? Okay. 3 minus 0. Everybody with me? So 2 minus negative 1 is what? 3 over another 3. And what's that? It's positive 1. So now let's take a look at these. Are these perpendicular? Yeah, absolutely. They're negative reciprocals of each other. The reciprocal part's not that big of a deal because if the reciprocal of 1 is just what? 1. Would you agree? All right. So they are reciprocals of each other, but one's negative, one's positive. Yeah, absolutely. They're negative reciprocals. That means they're perpendicular, which means that's a right angle. And what do we know about a quadrilateral if the diagonals bisect, or if the diagonals are perpendicular? What do we know about it? It's a what? It's a rhombus. Exactly right. So this is a rhombus, which means all 4 sides are equal. We could have done this. Okay, you have different options. And I think I wrote down all the options. So we know all 4 sides are equal. Do I know this is a square? If all 4 sides are equal, it could be a square. It might just not look like it. How would I know if it's a square or not? Something else about the diagonals. What's true about the diagonals of a square? They're congruent to each other, okay? So I could, I'm not going to, I'm just not going to waste the time right now. But I could, to make sure that it's not a square, because this could be a rhombus and this right here is not near of as steep of an angle. You know what I mean? It could be like just slightly off. of 90 degrees, right? And so it would be hard to tell if it was a square or not. But actually, it wouldn't be that hard because if you had points like this, you could tell if it went straight across or straight up and down. But anyway, if you wanted to determine if it's a square or not, what you could do is just take the distance, the length of those diagonals and see if they're equal to each other. So you could do the distance formula with AC and the distance formula with BD. Well, I actually did it, all right? Save you the work. So the distance of AC actually came out to be the square root of 50, and the distance of BD actually came out to be the square root of 18. All right, so do they have the same measurements, the diagonals? No, so it's definitely not a what? Square, okay? So it can't be a rectangle, all right? All four sides are equal to each other. It can't be a trapezoid, right? Yeah, because all four sides cannot equal each other on a trapezoid. It's definitely not a kite. All right, so we're good. It's a rhombus, and that's what they want you to do. Everybody good with that? Yeah. Let's see what else. Let's do example 2. Let's grab this. Now this is going to get, no, not this one. Example 3 is where we get a little bit kind of funky. Funky. It's such a 70s word. Does anybody say that anymore? Say that's pretty funky. All right, anyway, that's okay. It says, I guess, do you have the book open? On example 2, did they actually put a graph there? Okay, but they don't actually draw it on there? Okay. They don't give you any points or anything? Do they give you E and H? And they give you T as well, right? They don't? On mine, I wrote down, the question says, find the coordinates of F and G if the diagonals of that parallelogram intersect at point T, which is 3, 2. So they do tell you. Yeah, but they tell you, though. Okay, yeah, okay, that's what I thought. So they tell you it does that. All right, so I'll tell you what, let's move this a little bit more here. I'm going to make this a little bit bigger because they're only using that first quadrant. And if I only use the first quadrant on this, it's kind of small. So let's just make it a little bit bigger. There we go. Tell you what, I'm going to push this over here because everything's in the first quadrant. Is that all right? So I don't need that whole entire graph. All right, so they tell you point E is, oh, come on. There we go. They tell you point E is at the origin. Is that correct? All right. And they tell you H is at 4, 1. 1, 2, 3, 4, 1. That's H. What else do they tell you? They tell you that it intersects at 3, 2. So 1, 2, 3, 1, 2. All right. So it says find the coordinates of F and G, all right, which would be the, so here's E and H. That's the two vertices of my quadrilateral, okay? Actually, my parallelogram, they tell me it's a parallelogram, all right? So they do tell me it's a parallelogram, all right? And it says the diagonals intersect here. So this would be the midpoint of the diagonals, wouldn't it? You just follow me on that? So what do we know so far? Well, we know this is one of the sides. And what we need to do is find point what? F and G. Well, I tell you what you could probably do? Let me just see. Yeah. This is kind of a cheating way, but it'll work. You want to see it? So in a different color. There we go. If this is the midpoint of the diagonal, all right, so the diagonal is going to do what? It's going to go this way, agreed? And it's going to go this way. Now, it says it's a parallelogram. So they tell you it's a parallelogram EFGH. Let's write that down. So they tell you it's a parallelogram EFGH. G, and H, right? Everybody see that? So the F is going to be up here somewhere. Do you agree? And the G is going to be up here somewhere, right? There's the E, F, G, H. And this is the midpoint of the diagonals. So what you could do, start from this endpoint. How did you get to that midpoint? You went what? You went over 1, up 1, didn't you? So where is the other point going to be? Where's point F going to be? Over from the midpoint, what? Over 1, up 1. So right there, that's where F is going to be. Yeah? It's kind of a cheating way to do it, but it works. So it's good. It's not really cheating. So how do I get from E to that midpoint? Let's rise and run. So we went up what? 2 and over 3. So what am I going to do now? Go up 2 and over 3. 1, 2, 3. Boom, right there. That's where G is. Right there. Tell you what, let's make that one. Let's make that one pink. Is that all right? Just so the opposite sides are the same color. It doesn't make any difference. And there you go. So let's draw the diagonals. See, there's the one diagonal, and that's the midpoint of it. Agreed? Here's the other diagonal from there to there, and that's the midpoint of that diagonal. And there you go. So what are your points? Let's find out, because the whole problem says, what are the coordinates of point F and G? So what are the points? 2, what? 1, 2, 3. So 2, 3 is F. So F is at 2, 3. And G is at what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 4. Yep. There you go. That's the easiest way to do that one, I think. Now, it may not be always the most accurate. In this case, it is, because they told you exactly where this point was. It hit right on those. But what if they give you like decimals or fractions? That would be a little bit tough. Yeah, that's good enough. All right. Because I really want to get to this next one, because you'll see this on the test. Let's grab that and copy that. Let's move this up out of the way. Yeah, let's make this just a tad smaller. Okay. Now, this one is a little bit different. So they tell you the figure that we're going to draw here is a rhombus. And it's rhombus. There's no symbol. There's no like special symbol for rhombus. We just write it down, the word. So it's JKLM. So that's the rhombus we're going to have. And it says it's got diagonals. Now, this is where it gets weird. And what's true about the diagonals of a rhombus? They're perpendicular. Is that what you said? Yeah, they're perpendicular. And they also bisect each other because a rhombus is a parallelogram. Okay, so you know that. But here's what the diagonals, the lengths of the diagonals are. One length is 2W. All right, that's weird. And the other one is 2T. Okay? So what we're going to do, they didn't tell you any points on here. So, like, where do we start? Well, where do you think a good place to start would be if we don't really know any points? Probably be right in the middle, wouldn't it? Okay? So let's start right here. So what we're going to do is we're actually going to draw the diagonals, because that's the only thing we really know. We don't know anything about the sides of the rhombus, except that they're all equal to each other, okay? And that's important. But the diagonals, that's what we're going to draw. So watch what I'm going to do. the whole entire diagonal, I'm going to use this x-axis as my diagonal, and I'm going to use the y as my diagonal. So if the diagonal is 2w, and I'm starting here, okay, I'm just going to count out. Again, these place values don't really make any difference at all. I'm just going to count it out to like right here, all right? So I'm just going to draw it and let you see it. So I'm going to call this length W. So if this is my diagonal, how far over do I go to get my entire diagonal of 2W? Simone, you watching? This is super important. This is not the time to fall asleep, Zion. It's not the time to fall asleep. This is the hardest part. You're going to have this on a test in 2 days, all right? That's all I can tell you, all right? So this length right here is going to be W. And how many places did I go over? 1, 2, 3, 4. And again, it doesn't matter. I just want to be the same length, okay? So 1, 2, 3, 4 right here. So how far is it from here to here? What is that? That's W. Remember, I said this is going to be a diagonal, isn't it? So let's draw it. Tell you what, I'm going to make this just a little bit thicker, just so we can see it a little bit better. So I'm going to draw from here to here. Let's pop this up. There we go. See that green one right there? That's going to be one of my diagonals to the rhombus. Now, do the diagonals of a rhombus, are they equal to each other? Of every rhombus? No. It means they are perpendicular though, aren't they? Yep. So they are perpendicular. So that's why I made this one go across like this, just to make the perpendicular one kind of easy. Everybody with me on that? All right. So, and again, the diagonals don't have to be equal to each other, all right? And we could make them equal to each other because they could. It would just be a square. But let's make it look like a regular rhombus. This one over what, 4? Let's have this one go up 3. Is that all right? So watch. Again, this is the one endpoint to the diagonal. If I went up 3, how far am I going to go here? 1, 2, 3. And how did I know to go over W? Why? Because what's the length of that diagonal? It's 2W, correct? Right? And so what would this length be from here to here? Oops. Let's go back to 1 point because it's a little thick. All right? What is that point right there? That would be what? The other diagonal is 2t. This would be half of the diagonal. So how much would this be? This would be t. Then I'm going to go down the same amount to here. And so how far is that right there? That's also t. So what I've done is I've just drawn the diagonals. How did I know to draw them like along the x-axis and the y-axis? Well, you didn't. All right, you could draw it any way you want to, but it's just a lot easier drawing the diagonal. Since you know the diagonals are going to be perpendicular, you've already got 2 perpendicular lines here, don't you? It's just a lot easier. I mean, I could have started up here, right, and gone over W here and W here. Could have gone up T here and down T there. Could have started anywhere. It's just a little easier, I think, just to start at the origin. Okay, those are my diagonals. Let's draw the yellow diagonal from here to here. And let's push it over just a little bit. Do you see those two? The green one and the yellow one? Does it show up? Yeah, it shows up pretty good there. Those are my diagonals. So how am I going to draw my rhombus? What am I going to do? Just connect where? From where to where? From the end point, right? From the end point of this diagonal to the end point of that one. And then I just keep connecting. Everybody see this? There's my rhombus right there. What is the question, by the way? It says find the missing coordinates. So we're trying to find, let's make this back to 1 point again. Oops, I made it 3. Make it 1. Okay. So what are we trying to find here? We are trying to find what color haven't I used? This pink. Let's use that pink. What I'm trying to do is I'm trying to find that coordinate. I'm trying to find, let's find the missing coordinates. Yeah, let's find them all. Find this one, and find this one. That's what I'm trying to find. So we drew the picture. We got our diagonals. What's the diagonal? 2w. What's this diagonal right here? 2t. Everybody see that? So now, with that said, now I told you it was kind of weird, didn't I, at the beginning? So what are the coordinates of these endpoints, these vertices right here? What is the coordinate of that point? Well, how far over did I go? I went over, and let's give these some letters. We'll call this L. We'll call this one K. We'll call this one J. We'll call this one M. Did I just pull those out of the blue? No, because I'm using this one right here, right? J, K, L, M. You follow me? So I want to find the coordinate of J, of K, of L, and an M. That's what I'm trying to do. So let's go back to this. What is that coordinate right there? I start here. I go over this many. How many did I go over? You're going to say 4. 1, 2. Well, some of you might say 4. But it's not really 4. It's what? How far over did I go? I went over W, didn't I? So what's the coordinate of point L? W0. Very good. Okay, so I went over W and I went up 0, correct? What about K? So how did I get up to this point? I didn't go over at all, right? So what would my first one be? 0. And how far up did I go? It's T, correct. I could have picked any distance to go up, right? Would you agree? I could have gone more than this one. I could have gone less. It doesn't matter. So this would be 0T. What else do we have to find? J. Let's find J. How far did we go over here? Started here and we went what? Say it. I can't hear. Did I go W? I did go to the left, but I don't say, what's my coordinate going to be though? You're right. It is W to the left, but what do I write here? Negative W. That's right. Everybody see it? All right. And then how far up did I go? 0. All right. And then M, this one down here, what's that? 0, negative T. Very good. And that is what they're asking for. Kind of weird, isn't it? But it's not too bad. I mean, if you just, instead of calling it W, if you just called it like 4, that would make sense, wouldn't it? That point is at 4, 0. But I just arbitrarily picked 4 places over. Okay? What do you think? How do you feel about taking the test on Friday and doing corrections on Monday? Would you rather take it Thursday? Because I'm not done teaching this. Because there's more to this. Is this over at 10 till or 20? We have 1 minute. Okay, so it's 20. Yeah, let's do that because I really want to get through the rest of this, okay? Because the rest of them are kind of like this. All right, this one's actually one of the easier ones, all right? The rest of them are a little bit like this, but different shapes, okay? This is a rhombus. We're going to do a trapezoid, and then we're going to do a kite. We're going to do a rectangle, okay? So, yeah, tomorrow's short, but that's okay. We'll just start right at the beginning. I won't give you any pre-class talk or anything like I did today. All right? So let's do that then.